Okay, so welcome to section 3.3, which is continuously compounded interest. So continuously compounded interest, compounded interest. So remember we did sections 3.1 and 3.2 before our exam. So let's consider amount A is equal to principal investment times a quantity, 1 plus interest rate over number of times we compound n, all raised to the n times time. So let's go over that. We know that A is the amount, final amount, right? Maybe I should write final amount. Final amount. We know that, of course, P is the principal investment or principal amount. Principal amount. We know that the rate R is the interest rate as a decimal. N will be the number of compounds. Like if it's quarterly, that's 4 times a year. So number of compounds enacted. Say we've done 2 out of 4 quarters, that would be 2. So number of compounds enacted. And of course T is time. So T is time. Okay, so now I'm going to say something that's very formal, but bear with me. What color should I use? Let's use dark blue. So without loss of generality. So without loss of generality. I'm going to let the principal amount be 1, the time T be 1, and the interest rate be 1. So if I do that, then the formula above becomes what? Becomes A is equal to 1 times anything is just itself. So this becomes 1 plus interest rate is 1 over n raised to the n times 1 is just n. Okay, so for example, and this is going to be a calculator problem. So you're going to need to have your scientific calculator or maybe your pardon me, maybe your phone will do this, I'm not sure. So find A, the final amount, in the following. Okay, so number 1, if n is equal to 1, so we're using the formula above, we know that amount A, actually maybe should I, yeah, okay, I'll leave it here. A will be 1 plus 1 over n. So in this case, n is 1, so I'm going to plug in 1 for n. All raised to the n, which is 1. So what I get then is 1 plus 1 raised to the 1, which is 2 to the 1, which of course is 2. So I didn't really need a calculator for that one. Hopefully that one went okay. So now let's say if n is equal to 2. So what is the amount in that case? So it's 1 plus 1 over now 2, because now n is 2. raised to the n, which is now 2. So this becomes 1 plus 1/2. Okay, actually, 1 can be thought of as 2 over 2 plus 1 over 2 raised to the second power. So that becomes 3 over 2 squared. So that's 3 squared over 2 squared, which is 9 over 4. And you can plug that into your calculator. It's going to be 2.25. Okay, let's go on to number 3, where n is equal to 3. So in this case, the amount will be 1 plus 1 over now 3. What color should I use? So let's have n be equals to 3 this time. All raised to the now third power. So inside the parentheses, 1 is the same as 3/3. So I have 3 plus 1 over 3. All raised to the third power, which is 4 over 3. Now before I move on, notice that above was 3 over 2. Now we have 4 over 3. So it looks like the numerator is always 1 more than the denominator. So this will give us 4 cubed over 3 cubed. So 4 cubed is 64, and 3 cubed is 27. So that's going to be 2.370 bar when you plug that into your calculator. So what do you think is, well, let me do a few more. So number 4, let's have n be equals 2, 4, and then I'll start skipping a bit because this is getting a bit repetitive. So let's see. So let's say we have that the amount now will be equal to 1 plus 1 over now 4, right? Let's do this in, what color shall I use? This color. So now n is 4, all raised to the n, which is 4, the wrong color. Okay, so do you agree that 1 is 4/4? So what I really have is 4 plus 1 over 4, all raised to the fourth power. So that is 5 over 4. Once again, the numerator is 1 more than the denominator. Okay, so 5 to the fourth power is actually 625. And 4 to the fourth power is 256. And this becomes 2.44, etc. It goes on. But now let's skip a bit. Notice that no matter what, it looks like I'm getting a little bit taller. Like my value started at 2, went to 2.25, then to 2.3, then to 2.4. So it appears as though if I keep on raising the value of n, I keep on raising the value of the amount. But let's see what happens. So now let's skip to 10. So if n is equal to 10, then the amount A, let's do this in green, will be 1 plus 1 over 10. Let's do that in blue. All raised to the 10th power. And like usual, what do we get? We get 11 over 10. Now that I see the pattern, I know it's just going to be 1 more than the exponent on top, all raised to the 10th power. And what this gives us when we plug it in the calculator, and I'm going to put an asterisk right here. How do I plug this in the calculator? Well, let's see. 1, 2, 3, 4. Let's go down here. What I'm going to do is calculator input, calculator input. So in general, I know that what's in the numerator is 1 more than what's in the denominator. So in general, you're going to do n and then the button that has a plus on it, plus 1 for the numerator. Then you're going to press equal. No, you're not going to press equals. Well, I guess you can. Maybe not. Let's do divided by. Divided by n, right? For example, in this case, I've got 10 plus 1 divided by 10. Okay, so 10 plus 1 divided by, or n plus 1 divided by n. Why do I keep on writing n? Now you're going to press equals, because you want the value for the fraction. And then you're going to raise it to the 10th power. So there's a couple buttons that do this. On my calculator, I have the button y raised to the x, but you may have the calculator button that looks like a caret. So either one of these will work, and you're raising it to the n. Remember, the exponent here is the same as the denominator. And now you're going to press equal. Okay, so going back to our problem. So we've got 11 divided by 10. We'll press equals. Then we're going to raise that to the 10. And what we get when we're done, or what I got, is 2.5937, etc. So yeah, it's still, the decimal's still going up a bit. But what would happen now if I skip by an order of 10? That is, let's say I want to plug in n equals to 100. So what would the amount be in that case? Well, it's 1 plus 1 divided by 100, all raised to the 100. So n is now 100. So what's going to happen is I'll have 101, remember always one more, all over 100, raised to the 100. And when I did the math there, I got 2.7048, etc. Okay, so I've gone from 2.59 to 2.7. But remember, this was an order of magnitude greater. So let's do this again. Number 7. Let's say that we're going up to 1,000 now. Let's add another 0. So the amount A will be 1 plus 1 over 1,000, all raised to the 1,000. So what that's going to be is 1,001 divided by 1,000, all raised to the 1,000. So this should be a lot larger, given that n is a lot larger. But what's interesting is we get 2.71692, etc. Notice now 7 to 7, 1, whereas my difference was a whole order of magnitude. So it's getting bigger, but not very quickly. It's like plateauing, right? So let's try another order of magnitude. So let's tack on one more 0. Oh, by the way, I forgot to underline this one here. So for n is 1,000. So now let's have n being 10,000. So finally, let's do this in pink. So the amount will be 1 plus 1 over 10,000, all raised to the 10,000. And of course, we know that that gives us 10,001 all over 10,000 raised to the 10,000. And guess what? That gives us 2.718. So once again, I am not getting larger at all. It's like I'm plateauing. So what I'd like you to do now, if you have your computers out, computers, I mean calculators, is I would like you to put in your calculator, let's note. You should have a button that says So above the button, try to make this a square, that looks like an LN or maybe LNX, there should be an e to the x. So I'm going to show you how I would calculate that on my calculator. So I would do, so I have to do second to get above ln. Then I press ln, but really, because of the second, I'm going to what's above it, which is e to the x. Then I press number 1. Then I press equals. And what I get is 2.71828, etc. And this is actually e to the first power. So as n increases in the formula, A is equal to the quantity 1 plus 1 over n raised to the n, the amount, A, capital A, approaches. E. And let's note again. So note E is a transcendental number. Transcendental. Number whose decimal expansion is infinite and non-repeating, much like pi, and non-repeating. So formally, and you don't need to understand this, but this is how we define E in calculus. We say, pardon me, we say that the limit as n increases towards the infinite of the quantity 1 plus 1 over n raised to the n is equal to E. I hope that makes sense. So let's continue on, and let me actually, I'll define it formally as continuously compounded interest. So continuously compounded interest Okay, so as n increases in the formula, A is equal to principal times the quantity 1 plus 1 over n raised to the, r over n, momentito, r over n raised to the n times t. We arrive at the formula. We arrive at the formula for continuously compounded interest compounded interest. A is equal to principal now times E raised to the rate times time. Notice the exponent here is NT, whereas the exponent here is RT. So the acronym is PERT. So for example, let's actually use this. So for example, so let's suppose you invest. So suppose you invest. What shall we do? $500? $500 at a rate of 7% APR, annual percentage rate, continuously compounded. Continuously compounded. So what is the amount after 2 years? So what is the amount after 2 years? Okay, so what do we have? We invest $500. So do you agree my principal investment is $500? I know it's at a rate of 7%. So we have our rate is going to be 7%, which means 7 over 100, so 0.07. Remember the number of zeros preceding it is 2, much like 100. The number of time, t, is 2 years, so t is 2. And we can go ahead and plug in because those are all the variables, aren't they? So we're trying to find the amount A after 2 years. Well, we know that by definition of continuously compounded interest, that's going to be P times E raised to the rate times time, RT. That is the acronym PERT. So we have the amount will be $500 times E raised to the 0.07 times 2. Otherwise known as $500 times E raised to the 0.14. Right? Because twice 7 is 14. So how am I going to calculate this now? How will I find the amount? What am I going to plug into my calculator? So for me, what I'm going to do, the amount will be, now I'm not sure it'll be the same on your calculator, but it is on mine. This is how I do it on my calculator. What color should I use? What color haven't I used here? Let's do green. So I need to do second natural log because I need to get to the E button. So for me, that's second, ln, whatever that means. Then I'm going to, after that, do 0.14. Then I'm going to press equal. So that gives me e to the 0.14, but then I need to multiply that by the 500. So I multiply by 500, and then I press equal. And what I get for the amount after doing that is I get the amount equals to $575.14. So hopefully you're able to arrive at that. Unfortunately, because I can't see you guys, every calculator is different. But hopefully we'll survive. Okay, let's do another example. So a second and final example in this section. So find the interest. On $20,000 after 3 years. After 3 years of continuously compounded interest. Continuously compounded interest at a rate of 5%. Okay, so once again, let's see what we have. My principal, does everyone agree? My principal is 20,000. The time, T, is 3 years. Oh, wait, did I say find the interest? Oh, interest earned. That's what I wanted to say. Okay, well, find the interest earned. I wanted to say earned here, otherwise that makes no sense because I gave you the interest rate. So find the interest earned on $20,000 after 3 years. So time is 3 years. And my rate, which I gave you and then asked for at the same time, which was silly, is 5%, otherwise known as 0.05. Okay, so let's see if I can do this. So we have amount being equal to principal P times E raised to the rate times time. That is PERT. Okay, so let's plug in what we know. So the amount will be 20,000 times E raised to the rate 0.05, 5% times time, which is 3 years. So we get that the amount is 20,000 times E raised to the, so 3 times 5 is 15, so that's 0.15. Okay, so when I plug that into my calculator, and let me show you how. So the amount will be, let's do this green. So remember, I need to get to E to the X. On my calculator, it's second, then ln. You might have ln X. I'm going to press, I believe it's, 0.15 for the exponent. Then I'm going to say equals. So that will satisfy E to the 0.15. Then I'm going to multiply that by 20,000. So 20,000, and press equal. Now hopefully you get the amount, which actually isn't what I'm looking for, but you get an amount of 23,236.68. Okay, that's fine. That's an amount, but what am I actually looking for? I'm actually looking for the interest earned. So the interest earned is going to be the amount minus the principal, right? So the interest will be the final amount, A, minus the principal amount, P. So what we get then is going to be, actually maybe let me come down one line. So the interest will be $23,236.68, from which I'm subtracting the principal of $20,000. Okay, so my interest will be, what's left over? $3,236.68. So I hope that makes sense, and please send me any questions you have through Canvas.